Yeah.
Okay, so it's me and Ashish. We worked on the Q3 project for emerging technologies and big data, and we'll be presenting the project and sharing via YouTube. Okay, so let me hide the video and let's start with the presentation. Oh. Okay, so the topic that we tackling in this project is stock analysis for three companies, that is Google, Amazon, Microsoft. We're using a publicly available API called IEX Trading, which is a near real-time API, and it gives us stock prices uh, updated every minute or so. Uh, the solution actually uses NiFi for the scheduling of data ingestion. We read the data into MongoDB and Elasticsearch, and then we clean up the data. We're also using Azure notebooks to analyze and plot some informational graphs. So this is our overall architecture, where we have IEX giving us the API. NiFi runs a process every minute to call that API, write it to kind of cleans it up, writes it to MongoDB, then sends it to Elasticsearch. We can use Kibana sitting on top of Elasticsearch to do some visualizations or do some simple queries. For further analysis, we are reading the data into Azure notebooks. We're using Pandas data frame and Matplotlib to create graphs. So this is how the NiFi UI looks like. Because every company has their own URL, we had to create three NiFi processor groups: one for Google, one for Amazon, and one for Microsoft. All of them work exactly the same way, except that they set an attribute called company, which is specific to a particular firm. So I'll just open one of these stock processor groups to show you how it looks inside. So I just opened one for Google. So there, as you can see, it's a data a flowchart where the first step is to invoke the HTTP specifically for Google in this case. Then we massage the data, that is, we extract the attributes that we need to analyze. One thing that we found out while we were doing this was there was no inherent attribute in the original data set which we could use as a key. That is, it didn't tell us if this data was for Google, Amazon, or Microsoft. So we had to create a key based on the process. And also we didn't have a unique key on which we could assert the data. We didn't want to have duplicate data. So we have a step called update attribute, where it actually creates these two new fields and adds and concatenates existing data to form a unique key. As you can see, there's a step called split JSON. Now, this was required because when you call this API, everything comes in an array form, and you cannot load that JSON array directly into MongoDB. It doesn't work. So we had to use split JSON to split it into individual JSONs for every request. Like if at 9:30 a.m. one request came in, that would be a separate JSON. 9:31 it would be a separate JSON, and all of them then so all of them then are put in MongoDB by a step called attribute to JSON, which takes all these individual attributes that we had split up and then creates a new JSON document and puts it in MongoDB. And then from MongoDB, put in Elasticsearch so that it can be analyzed. So once the data is in Elasticsearch, as you can see, we created the index as Google stocks. Oh wow, it's a little misnamed, but that's the index name, and it's the same for Amazon, Microsoft, and Google. And then the doc type that we created was stocks. If you look at the query and the output of the query, you'll see that the index is Google stocks, type stocks. And one thing that differentiates the data coming from three different companies is this attribute called company, which in this case is for Amazon. So we know that this JSON has come in from Amazon. Side by side, we can run other queries and see that the data is coming. For example, if I had just had to limit the output data for Amazon and see what all stock information has come from Amazon, I can run this query and get the information. One more thing to note here is this key val, which actually we, as I explained in the last step in NiFi, we had to stitch together to create a unique key, so that every time a new packet came in, it didn't just create a duplicate; it actually just absurd what was already there. So this is what we have done, and I'll now hand it over to Ashish to explain how the visualization step was done in Python.
Okay, thank you, Vipul. So for visualization part, we use Azure Notebooks. So we connected the Elasticsearch. You can see here the connections was made by the IP, and now the challenge what we faced is the data what we received was in Unicode, which was difficult to work with. So we will first we had to convert into a Panda data frame, and for which we use the from section 6 to 9, we did the conversion part, so we can see the data into more in tabular form and write the queries for it. Once the data was converted, now we need to do some data cleanup. We need to convert the reformat and do the data conversion type, what you can see it in our step 10. Now we can start. We started querying against our data frame, and the first challenge we put ourselves for is to find out what was the worst trading volume for any given time for the day for Google. So in this case, you can see we had a query, and you can see that at time 13:49 there was zero volume for Google. So we just step up, and we wanted to see was there any more time where we had no trading for Google. And we wrote a query which shows now that for 10:28, 10:47, and all bunch of the times where there was trading values were zero. So moving forward, now we wanted to do some visualization. We were able to run some queries. Now we are trying to plot some graph for the number of trades for Amazon, Microsoft, and Google. So you can see here we use matplotlib for our visualization. So we wrote the queries for number of trades for Amazon. So we got so in this case, all the three different companies, we had three different data frames, and these are the graph. On the x-axis, we have the date time, and the y-axis, we have the number of trades. So this is first one is for Amazon, second is for Microsoft, and the third one is for Google. So now we stepped up, and we wanted to see how we can correlate and do a analysis to see at what time any particular stock did well. Is there any correlation between these stocks, because all these stocks falls under the tech group? So is there any specific time where this stocks does better trading? So there are two parts here. First, we tried to do a grouping, a two level of grouping to see what was the trading done on specific number of date time. So you can see here in the sections on the section 17, We have a query, and it gives us like particular date, time, what was the trading volume for each stock. And now we are using the graph to lay over all the three stocks, which shows um, with different color code what was the trading done on particular date time. If you see here in this graph at 9:40, right after 10 minutes when the stock market opened, that was the highest volume for Microsoft, and even the other stocks like Google and Amazon did pretty well around 9:40 of the date time. So it is pretty. It is this proves that it's very helpful for someone to do the analysis to identify uh, any specific given time if any stock is performing better or worse. So thank you. I will just hand it over to Vipul. He will talk more about the challenges what we faced.
Thanks, Ashish. Oh wow, we faced a bunch of challenges because, as the topic says, these are emerging technologies, and we don't really have much information in terms of implementations done by other people. Um, so the biggest challenge we faced here was learning the nuances of NiFi. That is, trying to make NiFi work, read the data in, and clean it and format it in such a way that it actually could be consumed by the technologies. That was the biggest challenge. The second biggest challenge was because we had to figure this out by ourselves. We had a bunch of Dockers running on our Azure VM, and we had to somehow make them work together. The third problem that we faced was how to visualize the data. Now, in the interest of time, we had to come up with Azure notebooks. But before that, we tried Kibana, but we realized that everything that we were getting after we had recreated the JSON in NiFi was string, and Kibana doesn't really work well with just strings, and we didn't really have enough time to find out how to convert that into integers so that we could just use Kibana for our visualizations. We tried something called helical search, but that doesn't really work well with MongoDB. So we ended up settling for Azure notebooks and using Python. That was a challenge in itself, as Ashish explained. But it gave us a way to quickly analyze the data and visualize it in form of graphs so that we could present something. Going forward, if we had more time and a little more help, maybe from other resources at our workplace or in amongst each other, if we communicate a little more, we would like to know how data conversions are done in Kibana itself, so that we don't have to go outside the NiFi process. So that's about it. That's what we have learned in this project. If you guys have any questions or you want to see the source code, everything is uploaded in Canvas, and you can go there and check it out. Okay, so thank you all of you. We are signing off and stopping the recording now. Thanks.
Thank you.